Good evening.
Good evening, sir.
Good evening, Nanika. Good evening, Chanakya. Okay, good evening to you all. Am I audible clearly?
Good evening, sir. Sir, actually, for the last two classes, I was absent, sir. I was not able to join. What has been done?
Okay, so actually the work done is shared in the group only. In the group only, we have shared what is done in the previous classes. Okay.
Okay, sir.
So you can just refer the group. The topics are there. In the last class, we clarified some of the doubts. We
Okay, sir.
clarified.
Are we still
uh,
doing the CBSE book, sir, or have we started the Pearson book?
we have completed the CBSE, NCRT, and now we'll be starting with Pearson.
Today,
Okay,
sir.
first,
From today?
before that, I want an update on your syllabus and your exams.
Sir, I'm
Which
actually
of
not
you
in
are likely
CBSE
to have
syllabus.
your exam?
Sir, I'm actually not in
Okay,
CBSE syllabus, sir. I'm in Cambridge syllabus.
okay, in your Cambridge school. So, anyways, you can share your topics to me from the
Evening,
group. You
sir.
can take out my number, and over there you can share. You can share your syllabus like this in the Cambridge. They share what topic will be coming for your exams
Yes, sir.
generally. So do share it. I
Evening,
also
sir.
have some books of the. Yeah, good evening. So even I have some books of Cambridge. So if you want that, will be I will look for the syllabus over there.
Okay, sir. I actually have all my course books for my exams, sir, and I'm also pretty much ready for my exams. This time I have density, heat and temperature, and conservation of energy.
Okay. There was someone who was having combustion and flame.
Yes, sir, I have conversion.
Okay. Okay. So I think we shall be doing today. We'll start a little bit with combustion and flame, and then we can.
Sir,
Yes.
I completed up to electric, chemical effects of electric current.
Okay. So that's nice. You have completed up to the chemical effects of electric current. Let me share my screen now. Okay, so all those who are from the CBSE part, is your complete syllabus for the exam clear? Just say yes, your exam syllabus is
Yes,
clear.
sir. Yes, so clear. Just the
Okay.
last chapter, the science that we are going to do.
Okay. Which is the last chapter? Combustion and flame.
No, sir, like in our
Hmm.
tuition, sir, everything the chapters are all the
Okay.
chapters are done, sir. Like
So,
compassion and payment, force and
okay, 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 no issues. No, no issues. No issues. Just let me. Nyanika, are you in grade 8?
Sir, what, sir?
You are in year 8 or grade 8 syllabus?
Sir, I will be considered as year 9, sir. In my school, they have skipped one of them. So we are actually learning year 9 syllabus.
Okay, fine. So that's what I wanted to know because they have grade 8 and year 9 are same.
Yeah, sir. That's what they consider at least. For the ninth class.
Okay. Okay. No, ninth class means grade 9.
Sir, like basically in our school, what they do is they start the 10th class syllabus books in ninth class only. So, like, what is it called? Year 10 is started in year 9 because that's how big the books are. Ninth class?
Okay. Okay. So let us start now. So we'll
Yes.
first start combustion and flame as one of them is getting that chapter. So let's do quickly what is combustion. and then we can start the topics. See, once your syllabus will be complete, so it's okay. So for combustion, let's see what is combustion. Combustion is the burning of a substance. The burning of a substance called combustion. Burning
So
of a
we're going to do
substance.
combustion of flames.
Yeah. So burning of a substance in presence of oxygen. In presence of oxygen is called combustion. So if you have any substance that burns, so that process will be called as combustion, and that burning process is completed in the presence of oxygen. So this process, as we know, that heat is an important energy resource for all of us. So generally to obtain the heat as an energy resource, we use this combustion. So we have seen in our surrounding different things which can burn and different things which cannot burn. So there are certain substances which can burn. So can you tell me the substances which can burn?
Uh, Matchstick, candle,
Sir, wood.
wood,
Yes.
and plastic containers.
Sir, paper.
Okay. You have combustible substances. There are certain substances which are combustible. For
Even
example,
there are
plastic.
luminous lights, sir, which we get light.
Yeah.
Sir,
We are
paper.
just looking for the substances which can be burned. For
Sir,
example,
paper.
plastic, wood,
Sir, paper.
table. Which one? Table.
Paper, sir, paper.
The paper.
Okay. Yeah, you have paper. So paper. Anything? Coal,
Sir, but
oil.
coal would like we can't. Sir, cloth.
Sir, trees, sir.
Sir, cloth.
Yeah, page or paper we have already written.
Sir,
Sir,
Yes,
trees.
any
cloth.
other?
Sir, but the coal. Flame, sir.
Sir,
Yes,
trees.
Coal
Trees.
does not produce flame.
please.
Yes, sir. That's like.
Yeah. So, okay, whether it produces flame or not, we are just looking for the substances which can burn and the substances which cannot burn, which
Sir,
cannot be
but
burned.
table is made of wood only, right, sir?
Oxygen, sir.
Yeah, table is made up of wood only, so it can be burned.
Sir, you don't
Okay.
put here wood.
Oxygen.
Okay, what
Oxygen.
are the substances which cannot be burned?
Sir, carbon dioxide.
Okay. There are certain
Non-combustible
non-combustible.
which
Okay.
cannot burn, sir.
Okay, non-combustible substances, they cannot
Which
Sir,
be
cannot
neon, sir.
burn. Iron.
Sir,
Iron can be
neon,
melted.
sir.
Sir, rubber, sir. Sir, metal.
Rubber can be burnt. Rubber
Sir,
Sir,
can
neon.
be
burnt.
burnt.
Sir, neon, sir.
Okay, neon cannot be burnt. And
Sir, stainless steel. Sir, sand, sir, sand. Stain.
okay, sand cannot be
Sir,
burnt.
Sir,
nitrogen.
stainless steel. Oxygen. Oxygen. Gases.
Oxygen is a okay.
Oxygen is a
No,
flammable
we,
gas.
yeah,
Carbon dioxide is
oxygen is
Sir,
made
oxygen
up
will
of,
be cutting off the oxygen will cutting off the fire, right, sir?
It's carbon dioxide.
No, no
it's
oxygen.
carbon dioxide. Oxygen will burn. You can say either oxygen will burn or there are other gases which will burn in
Sir,
presence of
sir,
oxygen. For
stainless
example, if
steel.
you,
Sir,
yeah,
if the uh, if a person is getting burning, like the mistakenly fire will be caught by the person, they will be rolling on the floor, right, sir? Then the oxygen supply will be cutting off so that the fire won't be. Sir, water.
yes,
Water.
water is also non-combustible. Very good. Okay, the
Liquids.
doubt regarding oxygen. Yeah, which one?
Liquids, sir.
Liquids.
Any
No,
liquid.
no.
Which,
Kerosene,
which
petrol,
liquids?
kerosene, petrol,
Oil.
diesel.
Even mustard oil burns. Even mustard oil burns. Even ghee burns.
LPG. LPG gas will be burning, right, sir?
Yeah, it is a combustible substance. LPG is also combustible. It is a highly flammable substance. So these are
Okay,
the
sir.
substances. There are certain substances in us which are combustible, and there are certain substances in us which are non-combustible. Combustible means they can be burned. So whatever substances are burning, they burn in presence of oxygen, and so you can write down or summarize the process to be of combustion to be something like this. You will have a combustible substance, and that combustible substance burns in presence of oxygen, or you can say reacts with oxygen to give you some amount of heat energy. It gives you some amount of heat energy. It also give you some amount of light energy also. It depends, but heat energy will be there. So combustible substance will burn in presence of oxygen and give you heat energy. You may also get light energy. So it's not necessary that you will be getting light energy every time, but yes, you may get light energy also. Okay. Now let us see what are the up to now we have seen the substances which can be burned and the substances which cannot be burned. So the substances which can be burnt, they are used for the combustion. The substances which are burnt, the substances which can be burnt, uh, they are used as fuels. Okay, so we use these substances as fuels. So can anyone tell me what are fuels?
So petrol and diesel.
Sir, fuel is the substance which is burning,
So
sir.
can you
It is reacting with oxygen to.
go to the before slide once? I'll just write it down quickly. Excuse me, sir.
Yes.
Can you go to the before slide one? Yeah, okay, thank you. Just a minute.
So stainless steel means like the utensils only, right? So like the
Yeah,
utensils
you
what
can.
you got.
Yeah.
And the other utensils will be getting burned, sir.
Other utensils generally do not burn. Okay, they
Like
oxidize
copper.
under.
Only like
Yeah,
the
they
wood
can be
and
oxidized. They can be, yeah, they can be oxidized under intense heat.
Yes, sir.
So here, okay, the next we are doing is fuels. So fuels are substances which are burnt to produce fuels. So what is a fuel? These are substances which are burnt, substances which are burnt to produce heat, and light. So necessarily we are burning those substances to fulfill our requirements. We are burning those substances to produce heat energy and light energy. So those substances, they are called as fuels. There should be certain characteristics of fuel.
sir, how
Once
do
we
you
are
produce
choosing a
light?
fuel, so it's like just like your candle. When you are burning fuel, you are getting candle.
Okay, sir.
Okay, so by burning candle, you are getting light energy. That's okay. Also, there are different ways by which you are raising light energy from the fuels. Okay, by burning lamps, that is also you are producing light energy.
Sir,
So
the
once we are
blue flame
choosing
is
the fuel, we have the ability to,
sir.
yes, we are
Sir,
not
so
talking of
blue
flames, we
flame
are
is
talking of
caused
fuels
by
right now. Mhm.
excuse me, sir.
Blue flame is created, yes.
Blue flame is created by plastic.
No, it's not plastic. Blue flame is created when any of the substance, any of the carbonic substance burn, but there is sufficient amount of oxygen. The amount of oxygen available should be sufficient enough. Okay. If
Okay, sir.
complete combustion takes place, then only blue flame is produced. For example, at your home, your gas stove, it produces blue flame.
Yes, sir.
Correct?
Yes,
So
sir.
the gas stove produces blue flame. The reason is that complete combustion is taking place.
They have the
If suppose
different types of
incomplete
color
combustion,
flames.
Say sometimes we'll get a green
yes.
and
So
purple also, sir.
okay, we'll be coming to that.
Sir, sometimes we'll get green flame and purple flame also, sir.
Okay,
And
we
sometimes
are currently just 1 minute, 1 minute. We are not on flames. We are on characteristics of fuel, not flames. It's fuels. Okay. So what should be the characteristics of fuels? Once I choose a fuel, so what are the points that I should keep in mind?
sir, I didn't
Suppose
answer
I want
about
a fuel for
this. I didn't understood about it.
okay. Suppose I want to choose a fuel for making food at our home, or suppose I want to use any fuel for any purpose at my home. So what should be the characteristics that should be there in that fuel? What do we expect?
So fuel is the gas which we will be burning the fire, right, sir?
Sir,
Yes,
there should
either we are using gas or we are using oil or whatever substance we are using as the fuel. Suppose we are using wood as the fuel,
sir, there are,
we are
sir,
using
fuels are,
coal as the fuel, we are using coal
sir,
as the fuel.
Sir, it should be
Yes,
sir, fuels are flammable, sir.
flammable, of course. That's
yeah, fuels are flammable. They are highly flammable substances. So, in what characteristics should be there? So, the first characteristic that I should look for a fuel is that it should have a high calorific value. So, Pranav, what do you mean calorific value?
Sir, the heat produced,
Pranav?
yes, sir. The heat produced when we burn 1 kg of a fuel.
Okay, the
The amount
amount of
of
heat
heat,
produced.
the amount of heat produced when we burn 1 kg of fuel.
Mm,
It is measured in
okay, by burning
it is
1 kilogram.
kilojoule per kg, sir. Kilojoule per kg.
Okay, so the amount of heat produced by burning 1 kilogram of a substance is called as calorific value. So it actually measures that how much amount of heat is being generated. So the highly efficient fuel, we want to burn small amount of fuel and obtain large amount of energy. At the same time, we also want safety of our houses. For example, the LPG that you are using at home, it is a 14 kilogram LPG cylinder that you are using. So that 14 kilogram LPG cylinder is used for cooking at your home, and I think it must be approximately lasting for about 30 to 40 days. Okay, so per day consumption of the fuel is approximately half a kilogram. See, just by burning half a kilogram of the fuel, you are you are cooking your food for the whole day. Okay, so can I say that the calorific value of the gas that we are using LPG is high?
Yes, sir.
Yes. Okay, can you think? Okay, suppose I give you 1 kilogram of wood and I want you to cook food for the whole day. Is it possible? Is it possible to cook food for the whole day by burning just 1 kilogram of wood?
Yes, sir.
Yes, sir. It is
No,
possible.
it's not possible. You might. It is possible. Can you cook at your home whatever food is being cooked? If you take 1 kilogram of wood, just 1 kilogram of wood, and use it for the whole day cooking. That's morning breakfast, afternoon, and evening. That's not possible.
No, sir.
Okay. Your 1 kilogram of wood would burn a maximum for around 10 to 15 minutes. That's the maximum time it will burn. And it's not possible to cook your food for that time. So the calorific value of wood is very less as compared with that. Also, the first thing, whenever we are choosing a fuel, we should look for its calorific value. It should have a high calorific value. And second thing, it should be safe.
Should be cheap, sir. It should be cheap.
It should be safe also, and it should be cheap or easily available. It should be cheap. That's what we are looking everywhere. It should be cheap.
It should be cheap and safe.
So whatever fuel we are using, the fuel has to be safe. That means it can be easily stored and transported. You can easily store at home. It should not be highly combustible. Okay. Lasya? Yes, Lasya? Lasya? She left.
Sir, it should produce less unwanted substances, sir.
Okay. It first, it should have calorific value.
Sir,
Yes.
sir, I don't know what
Yes,
happened, so my
friend.
power was not good, sir.
Okay,
Screen is
no
not even visible, sir, now.
issues.
Your screen is not visible, sir.
Okay, screen become visible, but whatever you doing, that's good.
Sir, your voice is breaking.
Okay, the
Yes,
screen
sir,
will
your
become.
voice is breaking.
Okay, just 1 minute. Let me see. Uh, okay. Is it okay now?
Yes.
Okay.
Sir, now I can't see your screen.
Now you can see.
No, sir.
No, sir.
Okay, just wait for just 1 minute. I think it will be loading. It takes a few minutes for loading. Actually, we had just had a rain. So because of that, maybe the networks have got disturbed a little bit. So you have the amount of heat produced by burning 1 kilogram of a substance that we call as the calorific value. So whatever substance we choose as the fuel, it should have a high calorific value. It should be safe and it should be cheap. The fuel should be cheap. Okay. What we also want is that it should be easy or it should be easily available. Consider a fuel which is very good. Okay, like we know about the nuclear fuel. Okay. Nuclear fuel is being used by the government to generate electricity in nuclear power plants. Is it possible that we can also use nuclear fuel at home
Sir, it's not
or
safe at
it's not safe? In the same way, we know about hydrogen fuel also. Hydrogen as a fuel, which is very good to use. It doesn't also create any pollution. So
but
if
it's
we
hard
use
to
high,
find, sir.
yes,
It's hard to find. It's very expensive.
it's hard to find and also it's also dangerous. Okay, till
Yes.
now we have not we are just trying to use hydrogen as a fuel in vehicles so that if we find it safe, if we are able to control the combustion of hydrogen, so we will be able to use them in vehicles which will decrease the amount of pollution. So what we are looking for, we are
Good.
looking for
You.
fuels. Yes,
Sir, what is the meaning of undergoes combustion?
undergoes.
Combustion.
Okay, just 1 minute. Let me see. I just remembered one more point. It should be a clean fuel. What do you mean by a clean fuel?
Sir, it should not release unwanted particles.
No.
Sir, it should be clean, sir. Means
In
it
what
will
way? In
clean
what way?
it.
In what way can we say to be a clean fuel?
Sir,
Is
means the
petrol
new ones, the fresh ones which is not used.
okay? Is petrol a clean fuel?
Uh,
Yes, sir.
Sir, I
yes,
have a
sir.
doubt, sir.
Okay.
Sir, I have a doubt.
What about? Yes.
Sir, even it depends on the climatic conditions, means it should not be in moisture.
For what?
The fuel, sir. Means does it even depend on the climatic conditions? It should not be in the moisture.
No, it's not necessary for all the fuels.
Okay.
Okay. So it should be a clean fuel. When I say clean fuel, it means it should not leave residue. Residue after burning. So for example, if you burn coal,
The
if you burn
residue means residue
residue
means
means the ashes which are left after burning of coal, the ashes which are left after burning of cow dung. Okay.
ash.
So
Ash.
there should, yeah, the ash or such substances should not be left behind.
Sir, I said that only, sir. Like it should not leave any unwanted particles after burning.
Yeah. So unwanted when we say unwanted, so that's certainly unspecific. So when I say that there should not be any residue, like if you have seen about the coal engine, okay, the earlier we were in the railway we were using coal engines. So the problem was that you have to feed the coal from one side, and you also have to remove the ashes from the other side. So there was always a residue left behind in the coal, in those coal engines. So that was a problem. Whereas with petrol and diesel engines, this problem is not there. And now even we are using the electric engine, so the problem of ashes is still not there. Why we are using LPG at our homes? The reason is that LPG is a clean fuel.
So
Otherwise, in our
petrol and diesel burn inside the car or the vehicle's engine.
yeah,
Do they evaporate like that?
Like, sir, LPG reduces pollution.
it does not reduce pollution. We can't say that
Biogas.
it reduces, but it doesn't cause pollution.
It doesn't cause more pollution than
Yeah, it doesn't.
like
Yeah.
petrol, diesel.
Yes, when we say it reduces pollution, then the symptoms becomes something different. Okay. If we have something that reduces pollution, so that will be a different. So LPG doesn't reduce pollution, but yes, with LPG, the pollution is less. Okay. So I think
Sir,
everyone has understood. Yes.
sir, when we when a gas at school or at the office, if the fire
Yes.
accident is going on, we won't use water, only fire extinguisher we use. For what? Like, why, sir? Why not water?
Okay. See, your fire extinguisher, as a fire extinguisher, we use different substances. We can use carbon dioxide gas as a fire extinguisher. We can use water as a fire extinguisher. We can use sand as a fire extinguisher. Okay. So out of them, all
Sir,
of
we can
them they are
also use
ready.
foam.
Foam. No,
Sir,
we can't use. Yes.
if we don't take all these precautions, which factor will the fuels affect, sir?
Which factor will the fuel affect?
Yes, sir.
Like, okay, just hold on for a minute. Let me continue first. Okay, hold.
Okay.
I'll be coming to it. So the fuel should be a clean fuel and it should be
So your
easily
voice is
available.
breaking.
It should have a proper ignition temperature. It should
So
have
your
a
voice is
prop.
breaking.
Is it breaking for everyone?
Yes, sir. Not too much for me, sir.
Yes, sir.
No,
Not
Okay,
much,
just
sir.
Yes, sir, it is breaking.
Sir, I know what is ignition temperature.
Ignition temperature means room temperature, sir.
no,
No,
ignition temperature is not room temperature. Ignition
Sir,
temperature is
the
the
time when the temperature at which it burns.
Okay. Yeah, the temperature at which a substance catches fire, that is the ignition temperature. For
Don't
example, you have seen that bear grylls producing fire by rubbing two woods in forest. Yes.
I
Anyone seen
yes, sir.
producing fire by rubbing? Yes. So producing
Yes,
fire
sir.
by rubbing is an example of the ignition temperature only. If you rub two substances, so the temperature of the substance increases.
Sir,
Sir,
stone, sir.
even when we are burning a matchstick with the matchstick box,
Yes.
sir, I didn't understood like when we burn the matchstick, it will be the fire we can see even when we burn the candle. But if we burn a um like uh,
Mhm.
agarbatti stick or
Mhm.
agarbatti stick or that samrani, we won't see the burning one. We will see the burning red substance. Why so it like why is it there? Like I didn't understand.
Okay, okay. So that will come to discuss when we discuss about flame.
Yes, sir.
Okay. When we
Yes.
discuss about the flame, then we'll discuss what are those things. Okay, so
Okay.
currently concentrate here. As we have seen such activities or such things we have seen, if you burn two substances, so heat is produced. Because of the heat, the temperature rises, and hence the substance starts burning. So therefore, we observe over here that once the wood reaches its ignition temperature, then it catches fire. The similar thing happens in forest also sometimes summers. During summers, what happens? Some branches they may get rubbed with each other.
Sir, the dry
They may
leaf,
get rubbed with each
sir,
other.
the small dry plant will catch fire, sir.
Yes. So the dried branches of the trees they may get rubbed with each other, increasing the temperature and hence catching fire. Okay. So whatever substance we are using as the fuel, it should be it should have a proper ignition temperature. So, so these are the conditions that a fuel should satisfy. If you are taking any fuel or if you are using any fuel, so the conditions are like that. It should have a high calorific value, it should be safe, and it should be cheap. It should be easily available or easily accessible to us. It should be it should not leave any residue after burning, that is it should be a clean fuel, and it should have a proper ignition temperature also. It should be easy to store that fuel, store and use that. Got it? So these are the necessary conditions that a fuel should satisfy. Got it? Okay. Now, out of the fuels which we are using, there are certain fuels which are fossil fuels. That means we obtain those fuels from the earth crust, which are the dead remains of the plants and trees. So certain fuels are obtained as fossil fuels, and certain fuels are there which are not fossil fuels. They are just fuels. For example, if you are using wood,
petroleum and coal, sir.
petroleum and coal, they are the fossil fuels. Okay, so coal and petroleum are the fossil fuels. The other fuels which we are looking at, they are not fossil fuels, they are the normal fuels which we can see. All right.
Petroleum is
Okay.
formed in Dead Sea creatures, sir.
Yeah, what happened?
Petroleum is formed in water, sir, by the Dead Sea creatures.
Yeah, we see all the living organisms, they contain, their body contains fatty acids. Okay. So when their body was decomposed under intense heat and pressure, so these fatty acids were there, which formed the petroleum. Yes, Lasya?
Yes, sir. Sir, I didn't even understood about red phosphorus and white
Red phos
phosphorus.
red phosphorus and white phosphorus, they are the two allotropes of phosphorus.
Like I
It is
didn't
common
understand,
chemistry,
sir.
no, sir?
Yeah, this is the
Yes.
chemistry. So like I didn't got what does it mean? Like I
Okay.
didn't
See, if
understand.
when we talk of allotropes, these are the allotropes of phosphorus. That means it is the same element existing in two forms. Okay. So you have red phosphorus and yellow
White.
phosphorus. Okay. You also have yellow phosphorus. You also call it as white phosphorus. So
Like
they
for
are the
me,
first.
only white and red is there. So like,
Okay. Okay. No issue. So in the same way, just not like this. There are different others also. For example, for carbon, we look different forms of carbon. So one of the form of carbon is diamond, and the other form of carbon is graphite. So both consist of carbon only. Both the elemental form, in both of them, the elemental form is carbon only. They do not contain any other substance. They contain carbon only. So, but the arrangement of the atoms of carbon is different in them, okay, giving rise to different properties. So that is the reason you have here. In the same way, you have two allotropes of phosphorus, the red phosphorus and white phosphorus. Okay. So the
yes,
phosphorus,
sir. Sir, yellow and white are same, sir.
yeah, white and red phosphorus.
No, sir. Like yellow and white phosphorus are the same.
Yeah, they are the same.
Okay, sir.
Yeah. So
Sir,
got
what
it,
is the
everyone?
C in this chemical?
Where C is carbon.
Okay, sir.
Okay, so carbon exists in two forms, diamond and graphite. Got it?
Sir,
Okay,
could you
so we'll
repeat again?
continue.
What is the C, sir?
Yeah,
C, C.
P is phosphorus.
Okay, okay.
Okay. Okay, so bye all of you. See you again. And who was having, I think, Nyanika. Yeah, Nyanika, if you could send your syllabus if you have. So I'll just accommodate accordingly. Okay, Nyanika?
Okay, sir, it's not that necessary, but yeah, sure.
Okay, 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 bye.
Yes.
Like, because it will be out of
Thank
topic
you.
for everybody else, right, sir?
Okay, okay, okay,
Bye.
Bye,
Tomorrow.
sir.
Thank you, sir.
okay, bye.